Welcome to the deep dive. Today we're jumping right in, really taking a massive intellectual shortcut, actually.
Yeah, we are.
We're looking at a theoretical showdown. Two huge ideas about what existence is, fundamentally.
Monumental is the right word. We're talking about computation versus coherence as the bedrock of reality.
Exactly. We're pitting Stephen Wolfram's physics project.
Yeah.
The idea that the universe is basically computation.
A giant evolving network, a hypergraph.
Right. Against Philip Randolph Lilien's unified coherence theory, UCT.
Which argues something quite different, that computation isn't the foundation, it's more like a shadow.
A projection, yeah, of something deeper, this idea of coherence.
But that's the core tension. Is reality built on process, on computation happening, or is it built on some fundamental state of being, of coherence, that allows process?
So for this deep dive, we've gone through quite a stack of material. The main one is a comparative study, coherence, causality, and the ontology of computation, plus some related UCT briefings.
And the headline conclusion from that analysis, it's pretty bold.
Which is?
That Wolfram's model, incredibly powerful and descriptive as it is, it's actually an emergent projection.
Emergent from UCT.
Yes, from the deeper structure that UCT describes. So our mission today, for you listening, is to bypass the summary level.
We want to get into the weeds.
Exactly. Understand the specific mechanics, the technical details, the philosophical nuts and bolts of both. We're focusing on the differences in their theoretical DNA, you could say.
Like how they define fundamental laws, what they mean by computation?
Precisely. The architecture of their invariances, that's key.
Okay, let's unpack this then.
Yeah.
Section 1, foundational principles. Where do these theories even begin? What's the starting point? Let's start with Wolfram.
Okay, Wolfram. It's all about computational relationalism. Meaning the universe isn't made of stuff in the traditional sense, like particles or fields as the most fundamental thing. Instead, the primitive entity is this abstract structure.
The hypergraph.
The hypergraph, yeah. A vast network. Nodes, connections. But more general than a simple network, edges can link multiple nodes. It's pure relationship, pure structure.
No underlying substance, just the connections.
That's the idea. Existence is the network and its pattern of connections.
And how does anything happen in this network? What drives change?
Well, that's the elegant part. Simple computational rules. Rewriting rules.
Like find a certain pattern, replace it with another.
Exactly. Tiny local updates applied over and over again, step by step. And the universe is that sequence of updates. Time is literally the progression of these computational steps.
So the ontology, nature of being here, is entirely process-based.
Totally. Existence is computation. Reality is the evolving network of causal connections generated by these rules. There's no need for anything deeper substance-wise. The relations are the reality. It's relationalism taken to its ultimate conclusion.
Okay, that's a clear picture. Powerful, too, connecting simple rules to complex physics. But then UCT walks in and says, what? How does it start?
UCT starts before the network. It posits an ontological source, something that exists prior to relation itself.
Prior to the hypergraph.
Yes. The primitive entity isn't a network. It's what they call the omnelectic field.
The omnelectic field, what is that?
Think of it as pure infinite coherence, a state of total self-consistent being. It's invariant, non-local, timeless. It's the absolute unity from which everything else derives.
Okay, whoa. That's a very different starting point. If you start with perfect unity, how does complexity, how does change even arise? If Wolfram has rules, what does UCT have?
The mechanism is called quantized coherence reduction.
Quantized coherence reduction. Break that down.
So instead of rules acting on a network, reality unfolds as this fundamental omnelectic field. Differentiates itself. It reduces its own perfect coherence step by step into asymmetry, but it does so in a way that conserves the total coherence.
Conserves coherence, like conservation of energy?
Kind of analogous, yes. It's a fundamental conservation law. But for coherence itself, all interactions, all structures, all physical laws are seen as emergent ways for this underlying coherence to be maintained, even as the field breaks its initial symmetry.
So we have this massive split right from the get-go. Wolfram starts inside the process, the relations, the computation.
Right, the focus is on the transformations within the network.
Well, UCT starts before all that with a principle of being, of coherence, that underlies any possible process.
That's the critical divergence, yeah. And from the UCT perspective, that whole intricate causal network Wolfram describes,
What about it?
It's seen as a projection, a lower-level constrained view, like a shadow, really, of these deeper coherence dynamics playing out.
So Wolfram's describing the execution of the code.
And UCT is trying to describe the underlying operating system, or maybe even the hardware principles that dictate which codes can run stably in the first place. It's claiming a level of precedence.
Okay, that leads nicely into the governing laws. Both theories rely heavily on invariance principles, right? This seems like a key battleground.
Absolutely central. Let's start with Wolfram's cornerstone, causal invariance.
Right. What is that technically?
It's a property of the rewriting system. It basically says, look, even though you might apply these little update rules in different orders locally.
Because it's happening all over the network asynchronously.
Exactly. Even with that freedom in the update order, the overall causal structure, which event caused which other event, ends up being the same. No matter the path taken through the computations, the fundamental causal relationships are preserved.
And that's huge because
Because it's what guarantees consistent physics. It underpins why observers moving differently through this computational process still agree on the fundamental laws. It's essential for getting things like relativity and quantum consistency to emerge robustly from the model. It ensures the universe doesn't just dissolve into contradictory causal histories.
a guarantee of relational stability. Makes sense.
But UCT looks at this and says, yes, that's true, but why is it true? UCT proposes a deeper invariance, coherence invariance.
Which we touched on, the conservation of total coherence.
Right. The claim is that this isn't just another invariance, it's the source invariance. Causality itself, and therefore causal invariance, emerges because the universe must conserve this deeper coherence as it differentiates.
Okay, hang on. If Wolfram's causal invariance is just an emergent subset, what does that mean? How does coherence conservation produce causal invariance?
Think of it like this. The fundamental drive is to keep the total amount of coherence constant coherence invariance. When this drive is forced to express itself through a sequence of discrete steps or events, which is what happens when you project it into layer 3, the relational layer.
The layer where Wolfram's model lives.
Exactly. The only way for that sequence of events to respect the underlying coherence conservation is if the order of those events doesn't actually change the fundamental causal outcome. So causal invariance becomes the temporal shadow of coherence invariance.
Wow, okay. So Wolfram identifies a crucial law governing the process.
And UCT claims that law is a necessary consequence of a more fundamental law governing being itself. One describes the shadow's consistency, the other describes the object casting the shadow.
That's a powerful analogy.
Yeah.
Okay, what about the nature of computation itself? Wolfram's view seems clear.
Yes. For Wolfram, computation is symbolic rewriting. Discrete rules applied to hypergraph structures. Find pattern A, replace with pattern B. It's fundamental. It's the primitive action.
But UCT uses the term computation differently, right? It happens at layer 2, the hololectic field.
Correct. UCT talks about the eigenvalue cascade. This is their version of computation, but it's not rule-based rewriting. It's described as a quantized resonance sequence.
Eigenvalue cascade. Resonance sequence. Sounds very different. What's happening there?
Imagine the omnelectic field vibrating or resonating. It can only settle into specific, stable modes or patterns, like the harmonics on a guitar string. These stable modes are the eigenvalues. The cascade is the process of the field differentiating by stepping down through these allowed, stable resonance states.
So it's not applying arbitrary rules.
No, it's selective resonance. The computation is governed by the intrinsic harmonic possibilities of the field itself, constrained by the need to conserve coherence. It's computation through coherence, not through symbolic manipulation.
So the rules aren't arbitrary inputs, they're outputs of this resonance process.
That's the claim. Wolfram might explore a vast space of possible rules, many leading nowhere physically meaningful. UCT suggests the universe inherently filters the possibilities, allowing only those rules or dynamics that correspond to stable coherence resonances. The allowed physics is pre-selected by the field's nature.
Okay, that's a fundamental difference in mechanism. Wolfram searches for the rule. UCT says the rule emerges from resonance. How does this play out with quantum mechanics? Wolfram uses the multiway system.
Right. All possible rule applications happen in parallel, creating this branching multi-way graph of histories. Quantum superposition is just being on multiple paths simultaneously. Entanglement is shared history between paths. Measurement is when these paths decohere or get resolved down to one consistent thread.
A very computational view of QM.
Definitely. UCT looks at that multi-way branching and sees something else. It sees the multiple possible pathways for coherence reduction. Each branch in Wolfram's graph is, in UCT terms, a different valid way the coherence field could differentiate while still conserving total coherence.
So the quantum possibilities aren't just computational branches.
They're reflections of the underlying potential in the coherence field itself. The uncertainty, the superposition, it stems from the field's inherent capacity to resolve into various stable, resonant states. The multi-way graph becomes a projection, a shadow of coherence modulation, as the source puts it.
All right, let's move up the stack. Section 3, emergent reality. How do the things we actually experience, like spacetime and particles, arise in these models? Wolfram first. Spacetime isn't fundamental?
Not at all. Totally emergent. There's no pre-existing stage. Space emerges statistically from how densely connected the hypergraph is in different regions. Think of it like the fabric woven by the connections.
And time.
Time is the computation. It's simply the progression of the update steps. So in Wolfram's model, time and causality are more fundamental than space. Space is the structure that emerges from the causal process unfolding over time.
And the big prize here is deriving general relativity, right? Einstein's equations just falling out.
As a large-scale statistical approximation, yes. The curvature of spacetime in GR corresponds to how information flows, how causal connections propagate through this hypergraph on average. It's a stunning result deriving continuous geometry from discrete computation.
Okay. How does UCT build spacetime if it starts with this continuous field?
It emerges differently. Space-time and fields arise from gradients in the coherence of this underlying field, specifically within what UCT calls the universal field tensor. It's not built up from discrete connections statistically, it's differentiated out of the continuum.
Gradients of coherence. So the geometry isn't combinatorial.
UCT describes it as harmonic geometry, a phase space resonance topology. The shape and structure of spacetime are dictated by the stable resonance patterns of the omnelectic field, like nodal lines in a vibrating plate.
So fundamentally continuous, but it looks discrete when projected.
Exactly. It appears discretely projective at layer 3, where the causal network lives, but UCT maintains the underlying reality is continuous and harmonically defined. It's a top-down emergence rather than Wolfram's bottom-up statistical emergence.
That's a really key distinction. What about particles? In Wolfram, they're knots.
Stable topological features, yeah. Persistent patterns or structures in the hypergraph that manage to survive the constant rewriting chaos. Little localized tangles of connections that hold together.
And interactions are these knots combining and splitting.
Pretty much. Recombinations of these stable structures, analogous to Feynman diagrams, but built directly from the network fabric. It's very elegant within the computational framework.
How does UCT see those knots?
UCT agrees they exist at the relational level, but gives them an ontological origin. Those stable motifs, those knots, represent the endpoints of the coherence reduction cascade. They are the specific, stabilized asymmetries that emerge when the eigenvalue cascade cools down into the derived field, layer 4.
They're stable because they satisfy the coherence conservation rules in a minimal way.
That's the idea. They are the most efficient, stable ways for coherence to manifest as localized asymmetry. So the knots aren't just accidental survivors, they are the necessary endpoints of the coherence reduction process.
Okay, this difference in perspective feels sharpest when we talk about the observer. What's the observer's role in Wolfram's model?
It's generally implicit, maybe even passive. An observer corresponds to a particular thread of computation, a specific way of sampling or tracing the evolution of the hypergraph. You follow a consistent path through the multi-way system. The observer is a complex computational process within the system.
But UCT gives the observer a much more active role.
Hugely active, fundamental even. The observer is explicitly defined as a coherence reducer.
A coherence reducer. Meaning
the active observation, the interaction of a conscious or complex system with its environment is actually part of the mechanism that causes the coherence field to differentiate. It forces the reduction from the potential states in layer 3 down into a specific measurable outcome in layer 3.
So, wait, does that address the measurement problem in quantum mechanics? Wolfram explains it as path selection, but UCT sounds like the observer triggers the selection.
It frames it very differently, yes. In UCT, measurement isn't just finding out which path was taken, it's the interaction that finalizes the path by forcing a coherence reduction. The observer, being a complex structure of already reduced coherence, interacts with the field in a way that resolves the potential into actuality, while ensuring the overall coherence is still conserved across the observer-system interaction.
That changes the philosophical status of the observer entirely, from a complex pattern in the computation.
To a fundamental driver of the universe's manifestation, it's a major shift in perspective.
Okay, this leads us straight into section 4, which feels like the core of the UCT argument, placing Wolfram's model within its own structure, this idea of an ontological descent.
Exactly. UCT presents this four-layer hierarchical architecture. It's designed to show how you get from pure unified being down to the messy, causal, observable universe we experience. And crucially, where computation fits into that journey.
The goal here is to show Wolfram's model is essentially contained within the lower levels.
That's the claim, that the Wolfram model describes a crucial part of the process, but not the origin of the process.
All right, let's walk down the layers. Layer I, omnelectic invariance, the peak.
The source, pure coherence, infinite simultaneity, absolutely non-causal, non-local unity. It's described as being as total coherence. The seed equation, a state of perfect, infinite self-consistency. No time, no space, no separation.
Now, you mentioned earlier the challenge of testing something like this. How does UCT address the criticism that starting with something non-causal and inaccessible makes it, well, unfalsifiable?
It's a valid challenge for any deeply ontological theory. UCT's justification is primarily structural necessity. The argument is that without such a perfectly coherent invariant source layer, there's no ultimate guarantor for the consistency and stability we see in the lower layers, like causal invariance itself. Layer A is the axiomatic foundation.
So its existence is inferred from the properties of the layers below it.
Precisely. And its testability isn't about directly seeing layer 1, but about whether the constraints it imposes, specifically coherence and variance, lead to unique, observable predictions in layers 3 and 4 that differ from models lacking this foundation. Think non-local effects beyond standard QM, perhaps.
Okay. And the Wolfram correspondence here is?
And 0, none, nada. Wolfram starts with relations, computation, causality. Layer 1 is explicitly before any of that can exist.
Right. Down to layer 2, the holectic field, the computational fabric in UCT terms.
Yes. Here, the pure coherence of layer I begins to differentiate, but still pretemporally. This is where the eigenvalue cascade happens. Remember the resonance. Lambda 2, lambda 3 derive. These are the stable modes emerging. It's computation via harmonic selection, not rule application.
And we said this layer provides the meta-rule space for Wolfram. Can you elaborate on that connection? How does a resonance cascade relate to specific rewrite rules?
Think of each stable eigenvalue transition, lambda right arrow lambda plus 1, as defining a class of allowed dynamics. It sets constraints. A specific Wolfram rule might be one concrete instance or implementation of the transformation allowed by that eigenvalue transition. So the cascade doesn't output a single rule, but defines the family of rules that are compatible with coherence conservation at that stage of differentiation.
So the holectic field essentially dictates the grammar of possible physical laws.
That's a good way to put it. It drastically prunes the tree of possible computational rules that Wolfram might explore, ensuring only those that resonate with the underlying coherence structure are available to form a stable universe. It filters out the mathematical chaos.
So Wolfram finds a rule that works.
But UCT claims it works because it's an allowed resonance selected here in layer 2.
Okay, layer 3, the relational field. This sounds familiar.
It should. This is where the rubber meets the road, causally speaking. The timeless resonances from layer 2 get projected into sequence and structure. Time emerges, causality emerges. Coherence now manifests as causal relationships. The network appears.
And the sources explicitly place the Wolfram model here.
Squarely within layer 3, the hypergraph, the specific rewriting rules chosen from the layer 2 possibilities, causal invariance as the governing principle within this layer. This is Wolfram's domain. UCT acknowledges it as an incredibly detailed and accurate description of the universe's relational dynamics. It's the map of the causal projection.
But not the map of the territory itself.
Not the whole territory, according to UCT.
Finally, layer 4, the derived field, the observable result.
Yes. This is where the causal structures developed in layer 3 stabilize into the things we actually measure and interact with. The final reduction of coherence into concrete asymmetry. Observers, particles as stable knots, specific physical constants, measurement outcomes, the tangible universe.
Which neatly corresponds to where Wolfram's model makes contact with reality-deriving particle properties, predicting quantum effects.
Exactly. It completes the picture. Layer 1 is the source potential. Layer 2 is the harmonic selection of allowed dynamics, the computation. Layer 3 is the projection of those dynamics into a causal network, Wolfram's world. Layer 4 is the stabilization of that network into observable phenomena.
It's a bold architecture, placing the entire edifice of computational physics as starting only on the third floor down from reality's penthouse.
It certainly reframes the hierarchy. It accepts the computational description, but seeks to ground it in a deeper pre-computational principle of coherence.
Now, for this whole structure to hold together, particularly the jump from the pre-relational layer 2 to the causal layer 3, UCT introduces something called the meta-operator, MathBBM. What does this do?
The meta-operator is the crucial bridge, the engine driving the descent. It's defined as a combination of two fundamental tendencies. MathBBS plus MathBS plus the meta is done.
MathBBS is the symmetry coherence operator. Think of it as the force pulling things back towards unity, towards the coherence of layer 1. It represents the tendency for coherence to be preserved, for symmetry to be maintained as much as possible. It's the conservation principle embodied.
The unifying force.
And
That's the asymmetry resonance operator. This is the differentiating tendency. It's the drive towards manifestation, complexity, structure. It pushes the system to actually undergo the eigenvalue cascade, to break symmetry according to the allowed resonances, to create the specific forms we see. It's the force of observation and becoming.
So MathBBM represents the balance or interplay between staying unified and becoming differentiated.
Exactly. It's the mechanism that allows the system to differentiate without violating the fundamental conservation law enforced by MathBia. It manages the coherence budget during the transformation from potential layer 2 to actual causal structure, layer 3.
Okay, and this maps back to Wolfram's model. How?
Beautifully, according to the sources. Wolfram's specific update rule, the thing that actively changes the hypergraph, that introduces asymmetry and drives evolution, is seen as a manifestation of MathBBM, differentiating operator.
The engine of change.
Right. And Wolfram's causal invariance, the principle that ensures consistency and preserves the underlying relational structure despite the changes that's seen as the expression of MathBBM, the coherence-preserving operator.
Wow. So Wolfram's two key elements, the rule and the invariance, are seen in UCT as two faces of the same coin, the meta-operator dictating the transition between layers.
That's the synthesis UCT proposes. It takes Wolfram's operational dynamics and gives them an ontological grounding within this MathBBA framework.
This also reframes the directionality, doesn't it? Wolfram is purely forward causal, step-by-step rule application.
Yes, a linear progression. UCT, via the meta-operator, suggests a kind of bidirectional influence. There's the forward push of differentiation, but it's constantly governed and constrained by the backward pull towards coherence conservation. It's not just step A leads to step B, it's that step B must be chosen such that it respects the overall coherence stemming from the source.
Okay, let's try to summarize this philosophical shift for everyone listening. We started by comparing relational process in Wolfram,
where existence is the computation, the evolving network.
to generative being in UCT.
Where existence starts with a fundamental state of coherence, and computation is how that coherence unfolds and manifests.
The hierarchy is key. Wolfram provides this incredibly detailed picture of layer 3, the causal computational layer.
An indispensable map of how the universe calculates. But UCT aims to provide the why. Why these calculations? Why this consistency? It traces it back to coherence invariance originating in layer 1.
And that final quote from the source material really crystallizes it. Computation is the visible shadow of coherence. Causality is coherence seen through reduction. The eigenvalue cascade is the true computational fabric, resonance as rule, coherence as code.
It's a profound reinterpretation. It suggests that the search for the ultimate laws isn't just about finding the right computational rule, as in Wolfram's project.
But maybe it's about understanding the right resonance.
Exactly. Finding the fundamental harmonics of the coherence field. UCT proposes these are two sides of the same coin. Mathematically, but conceptually, they start worlds apart. One starts with the process, the other with the potential governing the process.
Which leads to a really provocative final thought. If UCT is right, if this coherence invariance is more fundamental than Wolfram's causal invariance,
which is contained within it as a projection,
then shouldn't that deeper principle, coherence invariance, predict things that causal invariance alone cannot? What kind of unique phenomena, maybe deeply non-local effects or conservation laws, might stem directly from preserving coherence across the entire ontological structure? Phenomena that a purely relational causal model like Wolfram's might miss or struggle to explain.
That's the million-dollar question, isn't it? If UCT is more fundamental, its unique predictions are where it needs to be tested. That's something to think about.
Definitely something to think about. That's all the time we have for this deep dive.